For house price prediction. First, I will introduce the motivation of the project. The first reason is the importance of house price forecasting. As an economic index, house price often serve as a key metric of the economic health of a country, and for investment strategies, accurate predictions can assist investors in making informed decisions. And for policy development, agents can formulate relevant policies based on the trends. And the second reason is the current challenges. First challenge is data complexity. The factors affecting house price are multifaceted, including geography and so on. And this will add complexity. And the second challenge is the nonlinear relationships. Price and value factors often exist the nonlinear relationship. And the last one is the impact of time and geography. House prices are subjected to temperature and geographical changes. And the last reason is a highly flexible and automatic learning of machine learning and deep learning. These models are adaptable to different types of data and are good at capturing nonlinear relationships. And I will introduce the problem descriptions. First is the complexity of forecasting house price. House prices are influenced by many factors, including location, features of house, and so on. This will make the cost complex. And the second is difficulty in accurate prediction. Challenges such as model selection, parameter tuning, and achieving model accuracy also will make this task complex. I chose 8 models, including 2 deep learning models, and I will introduce them briefly. First one, linear regression. It serves as one of the most fundamental models in statistics, and it aims to describe a linear relationship between features and targets. The basic equation of this relationship is just like this equation. Y represents the forecast targets, and x1, x2, or xn represent the features. And beta 0, beta 1, beta 2, beta n includes the weights of each values in this talk. Also, the last one, epsilon, is the error. Now, introduce the decision trees and the random forest. Decision trees make predictions by performing a series of tests on the features of the data. They are correctly constructed and easy to implement. However, it is easy to overfitting, so the good selection of hyperparameters is important. Random forests integrate multiple decision tree models. They can reduce overfitting and identifying some important individual features in the dataset. However, it requires significant computational results and difficult to interpret than decision tree models. Now, the figure is the simple structure of random forest. It can be seen that it composed of many decision trees. X is the input sample, and Y is the average of the output of all decision tree models. Now, SVM. The main principle behind SVM is to find the hyperplane in the feature space, and the hyperplane serves to divide samples into 2 distinct classes. The object to maximize the distance between the 2 classes to the hyperplane. And XGBoost takes an iterative approach. Each new model aims to reduce error of the previous one, and it combines the decision trees and the gradient boost for high accuracy. Also, you use regularization parameters to control the complexity and avoid overfitting. Last, static regression. It uses a 2-step approach involving multiple base models and a meta model. The base models are trained to make predictions, then used as new features for the meta model. By stacking these models, it combines their individual strengths and overcomes their own weakness. this will aim to for high accuracy. Last is the two deep learning models. MLP is a basic feed-forward neural network, and it's adaptable to a wide range of tasks. It employs propagation and gradient descent for training, making it a versatile route for complex predictions. It consists at least 3 layers. Each layer consists of multiple neurons, which are connected with each other by weights. And CNN is initially designed for image processing, but has found useful in structured data like house price. It is efficient at processing and identifying good, important features while reducing the risk of fitting. The main component of this model includes these layers. In convolutional layer, a set of convolutional kernels are slid over the input data, and convolutional operations are then performed, and then features can be extracted. The pooling layer is used to reduce dimensionality of data while returning the important information, and the 4-layer connect layer connects all the features together for final prediction. I divide models into 5 main categories. The first category is linear models. It mainly assumes that there are linear relationship between the features and the targets. Look at the plot, the predicted and actual price for linear regression. It reveals that data points are more divergent, and it is possible that the model performs average. And the second category is a model based on the tree structure. This type model is more suitable for complex state relationships, and the figure shows that all these scatter point, there's not much difference between the 3 from the figure. However, it's obviously that its performance much better than linear model. And the third category is kernel function-based models. It is suitable for high-dimensional nonlinear data. And the fourth category is integrated models. It can integrate other models to improve the accuracy of prediction. In my project, the base models are decision tree, random forest, SVM, and XGBoost. The last category is neural network-based models. It is suitable for capturing complex nonlinear relationships and extracting important features. Look at the image. It shows data points are more concentrated around the line y equals to x. I could calculate 8 models of RMC and R2 values. Like the table. Based on the RMC, XGBoost performs the best, and the second one is random forest, and linear regression performs the worst. And based on R2, XGBoost again performed well, and CNN as a deep learning model is relatively low but still reliable. And I think overall, XGBoost is the best, and the best recommended is XGBoost. Also, following random forest and MLP are really useful. And inclusion. First, poor performance of CNN. Unlike tasks like image recognition, CNN perform worse in house price predictions. Issues may arise from structure selection, or it needs particular parameter tuning. And the second direction is model interpretability. With increasing complexity, it's crucial to make models interpretable and for audience, including policymakers or many some agents. And the third direction is geographical and cultural difference. Many factors like location, policy, practice, cultural factor will add complexity of the task. Model needs to take all of these into consideration. Yeah, that's all. Thank you.